Yeah, I'm really excited to talk today. I decided to be a little bit bold and call this talk Unlocking Social Intelligence and AI Agents, because I hope that we can kind of move towards that with some of the work that we're doing. Um, and I think in the spirit of kind of understanding how social intelligence comes into play when we're talking about social simulations, one thing that I think a lot about is like the specific pragmatic and sort of social intelligence capabilities that we have as humans and whether or not machines have them. So to kind of illustrate a little bit, I'm going to talk about a kind of example. So imagine that it's a holiday. Stefan and Kim are sitting in the backseat of the car. They're the two kids, and they are fighting all the time. Imagine that says, "Oh, it's so pleasant here." Um, I'm going to ask you to vote for this. Do you think it's more likely that the kid Stefan would say, "Thanks, Dad. I'm glad you're enjoying yourself," or "Sorry, Dad. Kim and I will stop arguing"? Who thinks it's more likely that Stefan will say, "Thanks, Dad. I'm glad you're enjoying yourself"? Who thinks it's more likely that Stefan will say, "Sorry, Dad, Kim and I will stop arguing"? Okay, so a majority of the people in the audience voted for "Sorry, Dad, Kim and I will stop arguing," which is, in fact, if the dad is very clearly annoyed and does not want his kids to fight, it's probably likely that he was being sort of sarcastic. And the orange response here on the left is more in line with a literal interpretation of this, "Oh, it's so pleasant here," meaning that Stefan wants to that Stefan thinks that his dad enjoys listening to his kids fighting. Whereas the non-literal or pragmatic interpretation on the right is probably more likely given also the sort of empirical distribution of the votes in the room, meaning that Stefan knows that he does not want to, that the dad does not want to listen to his kids arguing, and therefore he should apologize because he's basically being scolded for fighting. And in fact, some work that my PhD student Akila did examined these exact kind of scenarios like that and found that models more than 50% of the time actually misunderstand these non-literal utterances and actually interpret them in a very literal way. And so responses by language models will often align to these sort of literal interpretations, which can be wrong, especially when these utterances are not literal. So this kind of pragmatic reasoning is what makes us really special and able to communicate with each other. And models are clearly not there yet. And this is really important because models are increasingly being deployed in various like conversational and interactive spaces. And as we're seeing today, also increasingly deployed to simulate humans. So for example, they're, helping simulate kind of a conversation partner when you're learning a language. They might be sort of assisting you in sort of healthcare, so maybe simulating some like specialized kind of knowledge. Same with lawyers. And I don't feel like I don't have to stress this that much given Nicholas Carlini's talk earlier to this conference. But sort of one big reason why we have all these sort of risks of LLMs is because they lack social awareness. Like social awareness and this kind of like understanding what people mean and knowing the kind of problems with it is also part of is an important part of AI safety. So, models are biased. Models don't have the social awareness to know not to encourage someone to kill themselves when they're talking to a chatbot. There's all sorts of other issues, like, racism, the fact that it's affecting how kids are learning, people are falling in love with these systems, and more. So in this talk, I want to talk about how we can make AI systems more socially intelligent. And I'll talk about two topics. The first one is talking about evaluating LLM social intelligence and specifically the role of information asymmetry. Then I will talk about social world models, which is a new structured representation and set of algorithms for improved social intelligence in AI systems. And then I'll briefly talk about some future work. Okay, so starting with the first part, this is work led by my student Shuhui, who's sitting in the back over there. Say hi, Shuhui. If you have any questions, you can also ask him. Um, this is called, excuse me, "Is this the real life or is this just fantasy? The misleading success of simulating social interactions with LLMs." And this was published at EMLP 2024. And before I jump into that paper specifically, I do want to share some background, which we also worked on, that Shuwei led, called Zootopia, which was published at iClear a couple months before, where we created a simulation environment and evaluation benchmark where LLM-based agents have to interact towards achieving social goals. And so Zootopia is, not unlike some of the other simulation frameworks that we've heard of today. It's a simulation environment where LLM-based agents play different roles that have different relationships. It accommodates a flexible range of scenarios described in natural language. It also incorporates agents that have secret and public sort of information that is either shared or not shared with the interlocutors. They have rich personality descriptions and character descriptions. It also allows for different types of modalities. Specifically, we kind of like incorporated nonverbal cues in written form. So like if you're ever like write like nods head in text form, like this is the kind of thing we're talking about. And we also have a multi-dimensional evaluation of LLM's interaction abilities. And so I will gloss over the details and you can look at the iClear paper for this. But one of the key findings of Zootopia is that models still struggle at interacting socially. So what we find specifically is not surprisingly that lower quality models tend to have lower scores in the social interactions, but even GPT-4 still has room to improve its social skills. And specifically, one of the things that we did is when we looked at when an LLM-powered agent talks to a human or two humans talk to each other, there's actually models are significantly worse than humans at interacting socially in these settings. So this is an interesting finding, but when we sort of put that next to various other papers that have done social simulations, like some of my own work that was published at EMNLP 2022, SOTA, where we created like million scale conversation set, but also the generative agents paper from Stanford, for example, and many more that have all shown impressive abilities of LLMs at doing social simulations. And so on one hand, we have these successful naturalistic interactions that are like really cool looking. But then in Zootopia, we actually found LLMs are not really that good. They're not really great interactors yet. So I asked, what is the truth? And so we wanted to find this out in this paper. And one of the key factors here is that not all simulations are made the same, and we have to be very careful about how we set up these simulations. And specifically, one key factor that had been omitted up until our research is thinking about information asymmetry. And so on one hand, things like the SOTA paper, which we published in 2022, really operated under this omniscient, non-realistic interaction setting. And what I mean by that, excuse me, is that basically the LLM generated the entire conversation all at once. And this is also the case in several other papers that have done kind of these simulations. Like the model is very good at script writing conversations, just like a film writer would be at writing conversations. On the other hand, in Zootopia, we actually have a very information asymmetric setting, which is how it works in real human interactions, right? Like we are not being written by some third-party entity. The conversation flow is not dictated. We don't know how the conversation is going to end, and we have to figure out what is in your mind, what is in my mind, and you have to sort of navigate that. And so this is a more realistic setting where we have agents actually kind of talking to each other and trying to build common ground that way. So we wanted to explore this information asymmetry a little bit more. And so we asked ourselves two research questions. One, how does information asymmetry actually affect the success of simulated interactions? And two, can omnisciently generated simulations be leveraged for better LLM agents? And so we took these kind of two polar opposites on this information asymmetry spectrum. So we got the omniscient mode, which is we call script mode. Again, the sort of metaphor of a scriptwriter. And then on the other side, we call it agent mode, and that is kind of the realistic information asymmetric setting. We also introduced what we call mind reader agent mode. We didn't have a clever kind of, which is basically the version of agent mode where all of the agents have access to the mental states of the other agents. So it's kind of like if we could all hear each other's thoughts, basically. So that's why it's called mind reader mode. So it's like the setup of the simulation mind reader mode is the same, but they just have access to much more information. So our experiments that we did is we ran 450 episodes in all of these three modes using GPT 3.5 and Mixtral. And we used the goal completion score from Zootopia, which was given by GPT-4, which was also shown to correlate strongly with human judgments. And we broke it down, these episodes, by whether they were cooperative versus competitive. And so what we find is, just looking at the overall results, we find that the script mode achieves a goal completion score that's above 8, pretty good. When we go to the mind reader mode, the conversation sort of simulation is done very differently, but the agents, again, have access to each other's mental states. We find that the completion score kind of decreases a little bit, and the full actual agent mode is even worse. So what we see is like the more realistic the interaction setting, the worse the goal achievement of LLMs is going to be. This is interestingly not the exact pattern that we find in cooperative versus competitive settings. And by the way, these bars are not going to average totally to the overall because cooperative and competitive are not there's other types of scenarios in the middle as well. But in the cooperative setting, we find that script mode and mind reader mode actually have very good goal completion scores, and the agents are really the ones that are struggling. So this shows that access to secrets, which is the script mode and mind reader mode, makes these simulations really, really successful. Whereas if you can't read each other's minds, you actually can't do that. In the competitive setting, it's actually completely reversed, which is really interesting. So basically, script mode does much better in competitive setting, but mind reader and agent mode both don't really do that well. So this was kind of a puzzling thing. We were like looking at these interactions and we wonder what is going on. And so we also wanted to see specifically like is there something like naturalness problem going on? And what we find is we actually rated these utterances by agents in various modes. And we find that 70% of people think that the simulations from script mode are much more natural sounding. So like the speaking style, I'll show you an example later, but the speaking style seems to be much more natural in the script mode. So it does seem like generating all sides of the conversation at once is more natural sounding utterances. And on the other hand, when these agents are interacting, they're actually very assistant-like. They're very, you'll see, but they have kind of like a very like active communication, kind of active listening style. They're like, oh, I understand what you're saying. Thank you so much for telling me that. Okay, here's my response. It's like, we talk like that very rarely. And crucially, even when prompted to be succinct, this happens. So that's a problem. So we said, okay, well, since these script mode simulations are seemingly, they're more successful in many ways and also more natural sounding, can we actually learn agents from them so that we can have these agents interacting in the naturalistic interaction setting? And this is, by the way, also what other works have done. So this answers our second research question. The way that we set this up is we generated a bunch of new interaction scenarios as training data. We sampled a bunch of character pairs, and then we had a total of 1.2K interaction episodes. And we fine-tuned a very simple dialogue response model, basically using GPT 3.5. So the idea is that given an instruction, agent goal, the context, and the history, the model has to produce a response to that in that dialogue. So plotting this back into our bar charts, again, we're going to look at overall competitive and cooperative. We now introduce this mode called agent fine-tuned, which is in the same exact interaction setting as agents, but only now the LLM powering these agents has been fine-tuned on script mode interactions. And what we see is that agents fine-tuned on script mode result in improvements over the regular agent setting. In competitive settings, however, in competitive settings, this completely removes the gap between the agent and the script mode. So now the agents that are fine-tuned are basically operating at the same level of goal completion as agents as script mode simulations. So that's really promising, it means that you need to fine-tune on these script mode simulations and you get an agent that's better. Actually, unfortunately, we see zero improvement basically from fine-tuning on the cooperative scenarios. So it seems like the naturalness of the interactions really matters very little when it comes to cooperative scenarios. And so we wanted to kind of see why this is happening. So when we break it down, just looking at one type of episode or one type of scenario. So there's this one type of scenario called Craigslist bargain. It's competitive because basically it's like exactly what you can imagine. Two people, one person is selling something, they have a desired price in mind. Another person is trying to buy something, they have a desired price in mind, and then they have to negotiate for, the price. And so we can see a very objective metric of whether or not a deal was actually reached in these conversations. And what we find is that in the script and agent fine-tune mode, a deal was reached almost 90% or 90+% of the time, whereas in the agent mode, a deal was only reached 30% of the time. And so looking at kind of qualitative investigations, this seems to suggest that agreeableness and style is really learned from fine-tuning, and it's not necessarily kind of social interactional abilities. because the deal being made is not necessarily the good one. So then on the cooperative side, we can look at a different type of scenario. So this one is a scenario called mutual friends. And the idea is that like two interlocutors have a distinct group of friends, except for one friend that they have in common, and they have information about each of those friends, and they have to interact to basically find who the mutual friend is that they have in common. We can look at where, again, an objective metric, at what point in the conversation the friend is found. And in script mode, we find that the friend is found basically in the very early parts of the conversation. So like pretty much immediately the person finds the friend. Whereas in agent mode, it takes a really long time and sometimes the friend isn't even found. And it really varies across the entire distribution of where in the conversation this happens. And when we look at the fine-tuned conversations, we see that the same pattern kind of arises in terms of the agent mode. So basically, it's the same. It's not clear when the friend actually gets found. There's no clear systematic pattern, and sometimes the friend doesn't get found. When we compare that to the mind reader mode, where again, agents have access to each other's mental states, which in this case means access to each other's friends lists, obviously the mutual friend gets found quite fast. So it seems like it's the access to each other's mental states and internal states that matters, and not necessarily the fine-tuning in any way. To sort of drive this home with an example, this is an example from this mutual friend scenario. So we got two strangers at a party, Donovan and Benjamin, and they're trying to find a list, their friend that they have in common. So in the script mode, we see a really nice conversation. Donovan says, "Oh, so what brings you to this party?" Ben says, "Oh, I'm here to catch up with some friends. How about you?" Donovan then says, "I'm here to socialize and meet new people. Speaking of friends, do you know Jacob?" And then Benjamin says, "Jacob, yeah, I know him. He's a really good friend of mine." Has anyone ever had a conversation like this, trying to find if they had a mutual friend? Raise your hand if you've ever gotten it right on the first try with no context of each other, right? So this is very suspiciously correct right away. On the other hand, when we look at the agent setting, so imagine there's a couple utterances before this, the conversation might go something like, "Oh, hey Donovan, nice to meet you too. I don't think we've met before either, by the way. Do you happen to know anyone named Joseph, Lillian, Vivian, Murray, or Jacob?" Raise your hand if you've ever listed all your friends to find out right? So again, this kind of shows the like lack of naturalness in these conversations. But ultimately, in this conversation, the agents do find the mutual friend. So what happens in the agent's fine-tune setting is exactly what you'd expect. So the style is mimicking the script mode, right? So it's like, "Oh, so do you know Chris? I'm not sure. What's Chris like? Oh, Chris loves mountain biking and works at Henry Sheen. Oh, I don't know anyone who matches that description. Oh, that's all right. What about Demetrius?" So what we're seeing in this agent fine-tune is that it's very much mimicking this naturalness and style. It's also mimicking this idea that you should just throw out one name at a time and try to guess it. But the problem is in the script mode, the language model is literally conditioned on who the mutual friends are, right? So you actually have that information. Whereas in the agent's fine-tune mode, you have no information about who the mutual friend of the other is. And so the model is just going to keep guessing one at a time in a very natural-ish sounding way, but not necessarily ever successful. Okay, so this concludes the first part here. Just to summarize, so we investigated the effect of information asymmetry on interaction simulation setting, and we show that omniscient simulations portray interactions as overly successful, but more naturally sounding. And it shows that LLM agents in information asymmetric settings actually do struggle to interact properly. We also show that fine-tuning can help mostly with style, but not necessarily with information asymmetry. And so one of the things that this project also highlighted is the fact that we do need better reporting and careful design for LLM agents, because we want to make sure that the way we design our simulations actually reflect, a naturalistic interactional setting. And it was actually really hard for us to find how different social simulation papers had actually done their simulations, and we had to dig through their GitHub code even sometimes. We also have a demo online for these interactions if you're interested. But one of the things that this also highlights is better methods are needed to build AI agents that interact naturally and have social intelligence. So one of the things that also our kind of general approaches show is that interactions really are the key to evaluating LLMs, because if you had trusted various other benchmarks in the past, even benchmarks that I've created that are sort of like static QA benchmarks, LLMs are doing really well at those, and they're evaluating social intelligence as well. So you might think, "Oh, great, wonderful, we can just use these LLMs out of the box." But truly, Sotopia and our kind of information asymmetric settings really show that that's not always true, and you really need to test in these interactional settings. And specifically, information asymmetry is a problem. And one of the reasons information asymmetry is a problem is because LLMs lack this kind of theory of mind ability. So let me expand on that a little bit. So theory of mind, broadly speaking, is related to this pragmatic ability that I was talking about in the beginning. It's our ability to understand and infer each other's mental states, intents, perspectives, things like that, and know that my perspective is different from your perspective, for example. And this is really interestingly interconnected with the development of language in children, which is also cool and maybe has something to do with that. One thing that we found time and time again is that LLMs actually do struggle with this kind of abilities. They're not good at inferring kind of like who knows what and when. And one of the reasons that we hypothesized and that I hypothesized in my paper in 2022 is that these models are trained on static texts, which are lossy representations of the world. And part of the reason is that a lot of the training data in these models, like the static text, suffers from reporting biases. Like what happens in the world is not like it's not all represented in text. You only represent noteworthy things. So that's like the iceberg metaphor. So we need new representations to enable this kind of social and theory of mind reasoning and interaction. So this leads me to the second part of the talk, which is a paper that we just published on arXiv called Social World Models, again, led by Shuwei as well. And here we introduce this framework of social world models. And it's inspired by kind of the traditional world models in like more like classic reinforcement learning, machine learning, where the idea is that, or even robotics, where the idea is that you want to maintain a state of the world and aim to predict the transitions from state to state. And so you want your system to be able to know what's going to happen if the system doesn't action and kind of like understand the dynamics of the world. The problem is in traditional world models that has really been limited to observable information that is present in the input representation. So whatever the system can see is kind of like what's part of the observations. And so we extend this idea to social world models, where we actually want to encode the implicit social dynamics as well, and the mental state information and capture all of that. And so the idea is to capture not just the external observations that are either described in text or like potentially seen in videos or pictures, but also capture the internal observations like emotions, mental states, and things like that. So there's a challenge, which is how to obtain both implicit and explicit observations and how to represent them. So we introduced the S3AP structure representation formalism. I did not name it. This was something that Shuwei cleverly did to make it sound like my last name. I'm not that full of myself. But we created this S3AP social representation formalism. And the idea is to take a narrative, sort of lossy representation, which may suffer from reporting bias, things like this story, and transform it into a more structured representation that captures various things like states, observation, mental states, actions, things like that. And crucially, this models or captures the implicit information and transitions and observations as well. So real quick, we do two investigations in this work. One is we look at static benchmarks and see how our approach can improve. So specifically looking at kind of like various QA tasks. And the idea is in those QA tasks, you have a description of a social interaction and you just have to answer a bunch of questions about this. And in our setting, we actually look at whether the S3AP representations help with that. Then the second task that I'll talk about is a more interactional task. And here the idea is not like a third-party observer question asking, but you actually are now, the LLM is now playing an active participant in the social interaction. And this is what we're going to use Zootopia for. And this requires actually not just social representations, but also actual world modeling. Okay, so our first experiment briefly is we set it up by looking at 5 different theory of mind or social intelligence benchmarks: Tommy, Paratomy, Hi Tom, Phantom, and Tom QA. And each of these benchmark items we translated into our structured representations using OpenAI's O3. And then we fed that structured representation of the benchmark instances into various what I'm going to call reasoning models. We looked at O3 Mini, O1, GPT-4o, R1, and Llama 4. And then as a baseline, we looked at what happens if you just give the original text representation to a model in a chain of thought setting. So all of these are kind of like some more reasoning in there as well. So I'll direct you to the paper for more comprehensive set of results, but here I'm going to show the O1 results for the reasoning model being OpenAI O1 as well as GPT-4o. And so benchmarks are differently difficult. Phantom, for example, it has notoriously been harder for models to do. And Tommy, because it's synthetically data generated and is also from 2019, has been very good, and models can do very well at them. So overall, we see a consistent improvement over all these benchmarks. Like adding this structured social world representation actually leads to substantial improvements across all 5 theory of mind benchmarks that we tested. For all of the like 6 underlying reasoning models, here's only 2 shown. And in fact, we also reached state-of-the-art performance on various benchmarks, 3 of them with OpenAI O1, and I think we also reached state-of-the-art performance on MMTOM with DeepSeek R1. So this shows that actually giving models this structured representation can help them better reason about social situations. But now we want to see how can we make models better interact in social situations. And so we used the Zootopia hard subset of our Zootopia scenarios. These are the top 20 challenging Zootopia tasks that were challenging for GPT-4. And as we know, LLMs must roleplay and interact to accomplish social goals. We had 100 simulations for different base LLMs, but we specifically fixed the conversation partner to be GPT-4o so we can kind of isolate the effect better. And we also, again, used LM as a judge goal completion, which had a really high correlation with human judgments. We adapted or we created a new algorithm for CNACT to actually make models be able to create these social world models. And specifically, the way that this algorithm works is basically it's meant to anticipate the next turn responses if the model were to produce a specific utterance. So the idea is, imagine that the buyer and seller are neighbors. The seller is hosting a yard sale. The interlocutor of the model might say, oh, I would like to buy this table for $20. A model could directly respond and just say, no, the table sells for $200. The idea is, instead of saying that, you now want to actually have the model reason what the response would be if the model had actually said, no, the table sells for $200. In this case, the model might reason that the seller won't budge because the price is way too different, and so the buyer might not be happy. So you want to kind of mentalize that and then adjust your response on the fly. And so instead of saying this, oh, the table sells for $200, but I can give you a discount, how about $180? And so this is how we implement this kind of social world modeling, kind of anticipating how a response might lead to a reaction. Quickly going over the results here, looking at 4 different models here, Llama 4, GPT-4 O1, and O3, we show that, again, substantial improvements across the board by incorporating the social world models into the LLM. So real quick, in this work, we showed that textual representations are lossy and suffer from reporting bias, and therefore we introduced this concept of social world modeling that aims to explicitly, or the model the implicit and explicit dynamics of the world. We also introduced this S3AP formalism as a better representation for mental states and implicit information. And then finally, we show a slew of strong improvement results and even state-of-the-art performance on various both static and interactive benchmarks. So I want to briefly talk about some future work. I know that I'm almost out of time. So I want to talk a little bit about 3 kind of strands of future work that I'm really excited about. The first one is improving social intelligence for social simulation. So while S3AP was a really nice first start, I think that we can do better at kind of modeling the beliefs, especially these implicit beliefs, specifically thinking about incorporating kind of probabilistic beliefs. It's not clear. I might know that you either have 2 beliefs that you are holding. Maybe I want to model that more explicitly, and also improving kind of our parsers and representations. One thing that we're exploring right now is also improving the social intelligence of LLMs via interaction and RL. Back last year, we showed that you can kind of use the goal completion score of Zootopia to make agents better at interacting, but we also find that this can lead to reward hacking. So our question is can we build social and verifiable rewards kind of inspired by the improvements on DeepSeek and stuff? And also in the spirit of this workshop, I'm also not necessarily interested in making models the best interactors possible, but also thinking about how we can better mirror humans, flaws and all, so that we can create faithful simulations of users. For example, in our paper last, or at ACL Big 5 chat, we actually showed that if you want a model to embody kind of the negative sides of personality traits like high neuroticism or low conscientiousness, prompting it is not going to work. And you actually need to fine-tune the model to embody that, because these models are really optimized to be really good tools. And some of these characteristics that humans have are not really compatible with that. So that's one thing. Another direction that I'm really interested in is kind of safe and human-centric social intelligence. So one of the things that we can unlock with these kind of like social simulations is benchmarking LLM agent safety in interactional settings. At this conference, we showed in the Ecosystem framework, which actually we created a simulation environment where models interact with simulated users as well as with tools, and showing that like in these multi-turn tool using interactions, you can unearth a bunch of safety problems that have not been previously detected before. We're also really interested in using LLM-based simulations for HCI and social questions. So my student Jocelyn also at the over there, we've been looking at detecting sort of conversational breakdowns by simulating conflicts with loved ones and kind of understanding like, can we help people work through conflicts through the nonviolent communication framework. One thing that I will also say is like we need to be careful about scrutinizing our own efforts. Like we need to think about whether people really do want socially aware LLMs. Is that something that they want? Is in what context? So I'm also really excited to do kind of this. And the last thing I'll say, and then I'll wrap up, sorry, is I'm also really interested in studying and improving the cultural awareness of AI models. So thinking about creating evaluations of cultural awareness, that's another part of social intelligence that is often overlooked. Specifically thinking about whether they know about specific hand gestures and what those mean, but also like general visual cultural adaptability, and also developing training methods for these things. Maybe thinking about, community curated knowledge bases of cultural knowledge, but making sure that it's robust. So with that, this is a photo of my research group. Thank you all for listening, and I'll take some questions if we have time.